Hello. In this video, we're going to start talking about the different types of zeros. Now, just a heads up, the wind is kind of strong as I'm trying to record this, so if you hear anything in the background, that's just the wind. So polynomials can have rational, irrational, and/or imaginary zeros. For example, we want to classify zeros in the following polynomial function. We have f of x equals x cubed times x minus 2 times x plus 1/3 squared times x minus the square root of 5 times x plus the square root of 5 times x squared plus 4. Okay, there are several things here. First of all, these represent rational zeros. These represent irrationals. And the last one represents non-real complex. Now let's talk about why. Remember, when we're trying to solve something, we want to set the function equal to 0 and solve. That gives us zeros. So for the first three, notice we're not going to deal with the exponents. All we're dealing with is the base of the exponents. So the first one gives me x equals 0. The second one gives me x minus 2 equals 0. And the third one gives me x plus 1/3 equal to 0. Notice if I solve these, I have x equals 0, 2, and negative 1/3. Notice that 0, 2, and negative 1/3 are all rationals because they are all, or at least they can all be written as fractions. Now 0 is, think of it as 0 over 1, 2 would be 2 over 1, and negative 1/3, of course, is already a fraction. That's the reason why these are considered rational zeros. Notice the form that we have these in: x plus a number, x minus a number, or just x minus 0 there, same thing. For the next two, we have x minus the square root of 5 equals 0, and x plus the square root of 5 equals 0. That means we add the square root of 5 and we subtract the square root of 5, so it gives us square root of 5 and negative square root of 5. Now notice that there are radicals with these, and they are real numbers still, but they are in fact irrational because they have radicals still. Now notice that if I multiplied x minus square root of 5 times x plus square root of 5, what I would get would be x squared minus 5. Notice that this is not a difference of two squares, so it couldn't really be factored in the normal sense. But it can be factored like this. Or we can set this equal to 0 and solve. If I set that equal to 0, I get x squared equals 5, which means x equals plus or minus the square root of 5, which is exactly what we got here. They're the same thing. So as long as you can set it equal to 0 and solve, you will get either and you get a real number. You either have a rational number or an irrational number. Now this last one here, x squared plus 4, gives us non-real complex zeros. And the reason it gives us non-real complex zeros is because if you set x squared plus 4 equal to 0, subtract the 4, so we get x squared equals a negative value. And because it's x squared equals a negative, that gives us non-real complex zeros. In this case, that would be plus or minus the square root of negative 4, which would be plus or minus 2i. So these are, in fact, zeros of this polynomial function. But notice something. This is a sum of two squares. If you ever have a sum of two squares, that's going to give you non-real complex zeros. They don't always have to be a sum of two squares. It can also be something in the form of, let's say, x squared plus x plus 4. That would also give us non-real complex numbers. So as long as the discriminant of the quadratic is going to be negative, then we're going to get non-real complex zeros. And also you can only have them if you have a quadratic. Notice that these are all linear over here. So only if you can only break something down to the quadratic and no farther, whereas notice that this can still be broken down into quadratic. Basically, if the discriminant is ever less than 0, then that's going to give you non-real complex zeros. All right, Well, I think I've rambled on enough. I'm going to go ahead and end it here, and I will see you in the next video. Have fun.